Inverse functions. All right, inverse functions. Now, this is a very interesting topic, okay? So, the main point of inverse functions, right? The main point, right? If I have a function, f of a equals b, right? And a is my input, and b is my output, right? If I have a function, f of a of b, right? The inverse of that function, all right? The inverse of that function, right? The inverse, really, the inverse is denoted as f to the power minus 1, right? So the inverse of that function is going to be is going to be equal to, so the inverse of f of a, apologies, the inverse of f of a is really going to be equal to f of b equals a, right? So what am I doing here, all right? I'm basically swapping the input and the output, all right? I'm swapping the input and the output, all right? And to denote a function, to get the inverse of the function, let me put it in more familiar notation that you're used to. If I have f of x, right, it's going to be equal to some function, right? F of x is the function, yeah? So this is just notation, by the way, all right? This is just notation. Notation. No need for any other math right now. F of x, this means function, right? Well, f of the power minus 1 of x means inverse of function. All right, I know we're still a bit abstract on it, but we'll see how it works shortly. And the last thing what you should know is that only one-to-one functions, right? Only one-to-one functions have inverse functions, all right? A function needs to be one-to-one for it to have an inverse function, all right? So then let's move on. So this is a trick question here, right? Do you remember the test to check if a function is one-to-one? Do the horizontal line test. So the horizontal line test, it passes 2 times, failed. So it does not have an inverse, right? And the main reasoning really is because the inverse of a function needs to be a function as well. And this diagram here also fails the vertical line test, which is a test for a function. It fails that, and really, if we try to get an inverse of that, it won't be a function. It won't do us any good in this class. All right. So yeah. So we say determine whether or not the relations below will have inverses. Do you know what relations mean? A function is a relation. A relation is just any relationship between x and y. All right. But anyway, so if a function will have an inverse, it has to pass the horizontal line test. That's very simple. So yeah, this one will be good. No. All right, it's not one-to-one. Yeah, all right. And remember what I said. So if horizontal line tests good, right, it will have an inverse function, all right? So now back to the beginning of the statement to answer question 3, all right? Given the chart of f of x, fill in the chart of f minus 1 of x. What we're doing when we inverse a function is that we're swapping the x and the y, all right? We're swapping the input and the output. So if my regular function has a graph of f of x, as a chart, a table of f of x as such, right? So that would mean the values of my f of x will become my x values. So 3, 1, 0, minus 1, 3. And then x is going to become minus 1, minus 2, 4, minus 2, 0, 2, 4. All right? So, yeah. This is the last example. Don't worry, I got you. I'm not taking the video too long, and my iPad's about to die. Anyway, so given the functions below, find the inverses and verify that the inverses by graphing both. Okay, I'm not graphing them, but I'm just gonna show you how to find the inverse of a function, right? Anyway, so if I have f of x here, right, I gotta find its inverse. F of x is the same thing as saying y equals 2x plus 1, all right? And then your process, right, is literally swapping, all right? You're literally swapping the x and the y, all right? You're literally swapping the x and the y, all right? Just kind of put in a different color to highlight it to you, all right? Then you aren't done yet. So from here, what you're going to do is say x, sorry, apologies. From that stage, what you're gonna do is you're gonna have to solve for y. All right, you're gonna have to solve for y. All right, you're gonna have to solve for y, and what you're gonna get, right, in this case, you're gonna take the one across. It's gonna be x minus 1 equals 2y. Right, I'm just solving for y. I'm trying to isolate y. Divide both sides by 2. Cancel that out. Y is going to be equal to x minus 1 over 2, right? So at this stage of the game, you have finished. And that's the inverse function. So in that case, f of minus 1 of x is going to be equal to x1 over 2, right? That's really it, all right? We'll do some graphing examples in class, but really what you're doing, is going to what you're doing is just flipping the x and the y values to graph the inverse of the function, all right? And really, if a function is the inverse, all right, of another function, it has to be symmetrical over the line y equals x, all right? We'll talk about this a bit more if you remember your y equals x line. And but yeah, let me do a quick one really quick, just to really solidify the concept. Yeah, so if I have my g of x there, yeah, that's going to be equal to y 1 over 2x minus 6, right? And then 6 across plus y equals 1 over 2x, right? I gotta isolate the x. I'm going to multiply both sides by 2, right? 2 times 2 to get rid of the fraction. So I'm gonna cancel that, and then I'm gonna have 12 plus 2y equals x, right? And now I need to solve for y. So I take my 12 across. It's gonna be 2y equals x minus 12 over 2 over 2. Cancel that out. Y is equal to x minus 12 over 2. All right? And at this stage of the game, you have found the inverse of that function. So g of minus 1 of x is going to be equal to x minus 12 over 2. All right? And that's really the premise of everything, all right? That's really the premise of finding inverses. All right, so I know I'm moving a bit fast in class these days, but trust me, we'll all be ready for this final exam. All right, bye guys. Talk to you later.